Hey everyone, hope you are having a good session. So let's get started. Okay. So today, what are we going to look at is how can we move some of the most important activities that we are doing on the internet off of the centralized infrastructure that we are already using, right? And adopt a new type of apps, which are called trustless apps. But before we look into it and I explain you how to do that, I need to show you the current infrastructure and explain about some issues that we have with it. So, internet today looks something like this, which is usually there is a front end which talks to a backend server, which controls what type of actions a particular user can or cannot do on that website, on that service, and things like that. So, like if you have any account that you have created on any website, you have username and email and all of these things. So it's a normal flow where you authenticate to a backend server and then come back and then do some operations on top of it. With the architecture that I just showed, this it has served us very well in the for the past few years, right? And we were able to do things like, for example, with good UX, good low latency, and these kind of things. But it came with two key problems. What are those problems? Single centralized point of failures. So with the architecture that I showed you before, we have centralized single point of failures, and whatever is happening on those servers doesn't come with any form of computational integrity and data integrity with it. And it's sort of a trust-based system if you're using those services. What you're doing there is putting that trust in those companies and saying that they are not going to do anything malicious either with your data or with whatever form of things that you have stored there. And there are a few problems that come with it, which is they cannot delegate access to other people to use those services on their behalf, or like these servers becoming high-value target for hackers because a lot of these, all the identity of all the users that are there on these services are controlled by those servers. Now, I showed you the architecture, now the key problems. How do we do better? So the question is, can we do better? And the answer is yes. So what we can do in this, in the new architecture that I'm going to explain, which is replace our backend with smart contracts and P2P networks. And instead of relying on a server for doing any form of authentication, we can use UCANs and we can do we can do the JWT generation on the client side, right? And instead of credentials like username and passwords, we can use things like MetaMask or like wallets and ERC4337 wallets or multisigs. To help you visualize what would that look like in any app that you're thinking of building or if you're thinking of adopting a trustless setup. So there is a web client which is pinnable on IPFS, meaning it's think of it as a static piece of code that's there and will not change. Then you have this web client responsible for generating access tokens and also like managing the keys for the end user, which does one-time setup with the smart contract. And then you also have the peer-to-peer backend, which is sort of doing all the verification related to those credentials and talking to the smart contract for pulling those keys and doing that verification, right? And then after, in this setup, what will happen is web client will then be able to directly talk to the peer-to-peer backend and do all the operation that it needs for in that app. Now, I showed you the architecture, but what are the benefits? Why would you even think of adopting something like that? In this, the access can be granted on to any level of granularity that you want, right? What you could do is you could assign a limited set of permissions to one user, or you could assign, let's say, pseudo access to full users or these kind of things. There is no auth bottleneck. So if you have built any form of microservices type of architecture, you know that auth is the bottleneck there. And this type of architecture removes that. And it can work with any form of signature schemes. So the architecture that I explained about using smart contracts and relying on them for storing the keys, you could put any type of keys there, and you can then use that in your stack and for any form of verification like that. They can delegate subset of permissions. They can generate their keys, put it into smart contracts. They can do it on the behalf of the safes and the ERC-4337 wallets that they might be using. And with the architecture that I showed, where the backend is peer-to-peer, they get right to exit as well, which is they don't need to rely on one provider or one person for providing that kind of service. Now, what does that look like in production? Meaning we at Fileverse are using it. So we have a web client which generates UCANs for the users and has end-to-end encryption keys on the client side, which does one-time setup to the smart contract, putting those keys, public part of those keys onto a smart contract. And then our web client can directly talk to our backend infrastructure, which is open source and anyone can host, to do the operations like storing files, creating a Google Doc type document, creating a shared whiteboard, and all of these things without relying on one server for managing all of that. Now, I showed you the architecture, right? But does it come with trade-offs? Yes, it does. Meaning the web client needs to manage the keys, and how do you make sure that that web client is able to do that? So that's why I put a what's next slide. So there are a few things that needs to be solved, which is how can you get this architecture to work with ERC-4337 wallets? These are the things that we're looking at. And how can you get trustless recovery of credentials? Meaning whenever you generate these keys, how do you get the access back of these keys? You can use different recovery mechanisms that are already out there, but you could also come up with recovery mechanisms that are catering to different risk profiles of different apps. So to give you an example of that, there are 2-3 different recovery mechanisms that are interesting, and one of those we have, I and Andreas, we are working with the EF team to implement as well. It's called Recovery Pulse. So you can implement that with the certain risk threshold, and then you can get your credentials back of those keys. And once you have this kind of architecture, what the design space that it opens up is huge, which is you can come up with different coordination protocols that are not possible if you have a single point of authority that is allowing you to do whatever you can do. So think of it like this, that you can do a spec of a service, and that service follows the UCAN protocol and gives access to certain capabilities to some people and certain capabilities to others, right? So all of that will be possible if you follow this type of architecture. Then we also need to come up with different incentive structures so that other apps can also adopt the architecture like this and do different interaction patterns on top of it. So few things that you get with Fileverse right out of the box, just because of the stack that we have, which is right to exit, meaning you can move whatever service that you're using, which is hosted by Fileverse, and host it yourself, and say that instead of using Fileverse's service, you want to use something that you're hosting, right? You get modularity, meaning the way that we have built a web client, it's composable or it's modular. You can pick and choose different services that you want to enable or use or not use. You get cryptographic guarantees for access permissions, because all the access permission related things are done on the client side and are done using UCANs. So you get cryptographic guarantees that they are correct. And you also get data storage and availability guarantees from Fileverse. You're able to protect your anonymity and pseudo-anonymity as well by, like, for example, being able to being able to delegate the UCANs or permissions to someone else to use that service on your behalf. You also get composability because we are using smart contracts, meaning you can start using the Fileverse's stack with another smart contract that you just wrote, and you can mix and match different types of interaction patterns. Maybe you want to manage the access permissions using HATS protocol. Maybe you want to manage access permissions with something else that you just came up with, and so on. So all of that is possible because of the architecture. Now, I said right to exit, I think, multiple times. So why is this very important thing to have? So today, imagine this, like you're using Google for what, 5 to 10 years now, you have your entire history that's there, but can you take that data and move to another service? The answer is no. It's what you'll need to do is like export all of those files, then put all of those files onto another service. But what about the history or the comments that you did on a particular document that you created with someone? You're going to lose all of that, all of those, like that is part of your data as well, right? But if you follow or adopt the stack, the trustless stack that I was explaining, you get to create multiple services that can transfer data amongst themselves without having any form of centralized permissioning or any sort of issues. And the data is self-certifying with the content hash. So if, like for Fileverse, what we do is like we use IPFS for storage. So these services can transfer data amongst themselves in the self-certifiable way. And you cannot tamper with that data while doing that transfer. You get cryptographic guarantees to access permission. That's thanks to UCANs. So what you can do is like you can do authority delegation. You can do transfer of permission from one peer-to-peer network to another peer-to-peer network that wants to pull that data which you created on one network to that another network that you have. And I think the biggest thing that we are going to get out of this is like giving these kind of like interaction patterns to all the wallets that are out there. Meaning you have account abstracted wallets. How do you make all of those things work with an access permission that is that can be given or distributed like the UCAN's capabilities? So I think I'm done with the slides very quickly.